Okay, we are DMA 30. And for DMA 30, as we begin, we're going to begin here with section 1. And we are going to talk about what is a ratio. We're going to start with ratios. A ratio is a comparison of two numbers. When you write a ratio, it can be written in several different ways. You could write 3 with a colon and a 10. That would be 3 to 10. You could write it as 3 over 10 as a fraction, or you could write 3, the word 2, and 10. So when you have a ratio, it will be written in one of these 3 ways. The most common form that we are going to use is the fraction 3 over 10. If it's a fraction that can be reduced, like you would have had in DMA 20 when you work with fractions, if it can be reduced, then we do reduce that fraction. With the ratio, we still always have to have 2 parts to it. So for example, if we have the fraction 5 over 15, if that's our ratio, we can simplify or reduce that ratio because both of those numbers can be divided by 5. 5 divided by 5 is 1, 15 divided by 5 is 3. So any fraction you can divide by 1. This would reduce to its lowest term of 1/3. So you can reduce those fractions. Now, if we had something where we had, let's say, 24 over 6, if I reduce this, both of these numbers are divisible by 6 because we can divide anything by 1 whole. 24 divided by 6 would. Now, in this section, you cannot use the whole number 4. Just the whole number 4, I'm going to make note, can't be used. You still want to keep your answer in the form of 4 over 1 because you have a comparison of 4 of these to one of those. So even though that would reduce to a 4, if in this section you're writing an answer as a ratio, keep it in that fraction form. If you'll turn in your workbook to page 3-5, let's look at how to write the ratio as a ratio of whole numbers using fraction notation. So here we have a fraction of, it says 11 to 22. 11 to 22. So when you type in 11 over 22, that is how to write it, but we want to write it in simplest form. So as a reminder, if you're using your calculator, type in 11 divided by 22. Press enter, you get a decimal. When I simplify this, we're going to press math, enter 2 times, and that reduces to 1 over 2, 1/2. So 11 over 22 is going to reduce to 1/2. Both of those numbers are divisible by 11. If I have 10 weeks to 2 weeks, that would be 10 over 2. Both of these can be divided by the number 2. They're both even. If we take 10 and divide it by 2, we get a whole number 5. When I get the whole number 5, what did I just mention in the previous slide? We still have to have the answer in fraction form, so we're going to write it as 5 over 1. We have 20 over 35, $20 to $35. Okay, so 20 to 35, and we're going to do math, enter twice. That's going to give us 4/7. 4/7. There are 24 women and 22 men in a marching band. Find the ratio of women to men. Now, this is something I recommend you do as you're working through our problems. When they give you a ratio with words, we're doing a comparison of women, that's the numerator, men's the denominator. So usually I like to make some sort of notation on paper so when I come back and I write my numbers down, I'm putting my numbers in the correct location, whether it's the numerator or denominator. So we've got 24/22, math, enter, enter, 12/11. Now this next one looks a little complicated. We have 3 1/2 over 2 3/8. That looks difficult, but it's not going to be hard to do. We're going to use our calculator. It's our mathematical tool. It's like our hammer of construction. It's our hammer of the math classroom. Okay, so when I do this, let me show you another way, a way you can actually type a mixed number. Use alpha, y equals, and I'm going to choose number 2. I'm going to type in my 3 and then 1. I'm using the arrow keys just to move that around, 3 1/2. Then I'm going to do the divided by alpha, y equals. I'm choosing number 2 again, which is my mixed number, and I'm going to type in my 2 3/8. Enter, 28/19. Okay, let me. Okay, so we have one last question, and this one is one with a decimal. We've got 2.4 to 10. So when you write it down, write it as a fraction, and then again, we're going to use our calculator, 2.4 divided by 10, and then math, enter, enter, 6/25. So any of these, don't complicate them. Don't do things the long way. Just work these as simplistically as you can, okay? Another thing, and as I said, this is turn over to page 3-7. We're going to work on some more. When you're on 3-7 and we're looking at these particular problems, we are going to have a word problem. And this is where you'll find that it's going to be important to start using words or letters to make note of where things go. This question is, last week, Shane worked 45 hours. This week, he worked 50 hours. Find the ratio of the increase in hours to the previous week of hours. Okay, so we're doing a ratio. The numerator is the increase in hours. So the numerator is the increase in hours over, it says, to the previous week of hours. So that's previous week of hours. So last week he worked 45 hours. So that would be the previous week. That would be the denominator. This week he worked 50 hours. The ratio of the increase in hours. So if he worked 45 and then it went up to 50, that's an increase of 5. We would take the 50 minus the 45, and 5 would be the increase in hours. And then we're going to take the 5/45 and we're going to reduce that, and that would give us 1/9. If you look at your number 8, it says find the ratio of the longest side of the triangle to the perimeter. Okay, so I'm just going to write down long over PER for perimeter. Here's my triangle. I've got 6, 7, 9. So when I look at this, what is the longest side? It will be the side that's a 9. How do you find the perimeter? For the perimeter, you're going to add all sides. So we're going to do 6 plus 7 plus 9. That's going to give us a total of 22. So we have 9 over 22. If I could reduce that, I would, but in this case, this one will not reduce any further. Let me jump down to number 10. Find the ratio of triangles to circles. So when I make my little notation, triangles is in the numerator, circles in the denominator. As I count my triangles, I have 1, 2, 3, 4, 5, 6. So 6 is my numerator. Circles, I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 circles. And then we would reduce that. They're both even, and that would reduce to 3 over 4. Okay, so that's all that we're doing as far as ratios. Okay, and take the ratio and simplify. Now, the next thing in this same section we're going to look at is something called the unit rate. A unit rate is when you have a denominator of 1. Any rate can be converted to a unit rate by dividing the numerator by the denominator. So to find the unit rate, you're going to take numerator, divide by denominator, and that gives you your answer, which is called the unit rate. This one will not be written in the form of a fraction. So all right, let's say you went to the gas station, and let's say you had looked at you had set the amount of mileage at 0 the last time you had filled up. And let's say you had driven 200 miles, and when you filled up your gas tank, it took 10 gallons of gas to fill it up. So if I want to calculate miles per gallon to find the MPG, which is the miles per gallon, we would take 200, we would divide it by 10. So 200 divided by 10 would give us 20. So that means we will be getting 20 miles per gallon of gas on our car. So oftentimes people might calculate your miles per gallon. You might calculate miles per hour as far as how many miles you drove and how long it took to get there. That's a miles per hour. If you're going to a store and you're purchasing something, let's say you're doing a comparison of purchasing, let's see. Okay, let's say you're buying ketchup. Let's say there's a bottle of ketchup, and let's say it costs $2.50 for a 16-ounce bottle of ketchup. We'll call it ketchup A. Well, it's all going to be the same ketchup. We're just going to do different sizes of it. And let's say we have another one, and let's say it's $4.25, and the bottle that's $4.25 is 24 ounces. We want to calculate which is the better buy. So what we're going to do is we're going to calculate a price per ounce. So we're going to do divided by 16, and over here we're going to do 425 divided by 24. Okay, so if I do 250 divided by 16, That's going to be, now with money, in this case, we're going to go out 3 decimal places. I know money normally goes 2, but we're going to go a third one just in case they're close to each other. So a 0.1562, if I'm going 3 places, the 2 makes the 6 stay the same. So that's going to be a 0.156. For the next one, the $4.25 divided by 24 ounces, that's going to be for 3 decimal places. The 0 makes the 7 stay the same. So that's a 0.177. So when I'm calculating, this one is about 16 cents an ounce, and this one is about 18 cents an ounce. So which would be the better purchase in this case? The smaller one. So when you're asking, in this case, for the better buy, it would be this one, because this would be in essence 16 cents an ounce. This one would be 18 cents an ounce. So that would be cheaper. Sometimes buying big is not always cheaper. This is just numbers randomly that I made up. So do comparisons. And when you go like the food line, Walmart, different places, look on the shelf, you'll see the label stuck there. And oftentimes they will go ahead and have calculated that, and they will show that to you. So you'll actually get to see that. You have some other examples of ratios calculating how much it costs to buy cans of soup, doing a price per ounce. So that's an additional practice that you have. The next thing we're going to look at in section 2, as we move into section 2, this is a section on proportions. Proportions are 2 ratios that are equal. In other words, it's like equivalent fractions. For example, if I have 3/6, and let's say I have 4/8, these are proportions. Now, let me show you an easy way to keep up with and see if 2 items are proportions. A way that you can check proportions is to cross multiply. So if I multiply 6 times 4, that gives me 24. If I multiply 8 times 3, that gives me 24. If these 2 numbers, if those numbers are the same, then I would say yes, it is a proportion. That means they're equivalent to each other. If I reduce the fraction 3/6, isn't that 1/2? If I reduce 4/8, isn't that also 1/2? They are equal to each other. So proportions are 2 ratios that are equal to each other. It's just the numbers aren't written the same as a 1/2 and a 1/2. It's a 3/6 and a 4/8. But if you cross multiply, you can see if they are proportionate. Okay, let me give us another example. And my question is going to be, are they proportions? And the answer is just going to be yes or no. Are they proportions? Okay, we're going to have 5/6 and 9/7. And these problems you'll find located on page 3-17. I always believe if there's a chance we can do some stuff together and help work through some of your other problems, then we do them together like this. I don't always have time to do all of the problems, but I do try to use some of these as my examples. Okay, so for each of these, on this first one, if you got your calculator handy, what is 9 times 6? That gives us 54. And what is 7 times 5? That gives us 35. Those are not the same, so no, that is not a proportion. 36 times 2, that's going to give me 72. 9 times 8 is going to give me 72. Those are the same, so yes, that will be a proportion. Okay, I'm going to use the calculator. We've got 6 times 5.4, 32.4, 32.4. And then I'm going to do 8 times 3.6, 28.8. So this one is going to be no, not a proportion. So just by cross multiplying, you can check to determine if they are a proportion. Now, this part, we're going to apply this and we're going to figure out, find the unknown number. Okay? So we're going to find the unknown value. So n over 5, 6 over 10. Okay, so when I solve for the unknown value, let me just jot this down in words here. What I'm going to ask that you do is to multiply the two diagonal numbers, then divide by the number paired with the unknown. Like on this problem. If I didn't know what the 3 was, I'm going to pretend like the 3 is not there. 6 times 4 would be 24. 24 divided by 8 would give me a 3. If the 6 was missing, I would say 3 times 8 is 24. 24 divided by 4 would leave me with the number 6. So that's kind of how we're going to do these problems. I'm going to take these two that are diagonal, and I'm going to do 6 times 5 divided by 10. So I cross multiply and divide by 10. 6 times 5 is 30. 30 divided by 10 is 3. So our missing value here is going to be a 3. And you can do these using the calculator as well. And this next one we will when we get to bigger numbers. So we're going to multiply. We're going to do 12 times 16, and then we're going to divide by the 10. So 12 times 16 divided by 10. You can type it all in on one row, and that gives you 19.2. And then one more. We're going to multiply. So we're going to do 7.8 times 2.6 divided by 1.3. 7.8 times 2.6 divided by 1.3. 15.6. So when you're trying to determine an unknown amount in a proportion, I will use the term, you'll hear me say, cross, multiply, then divide. So you cross multiply the two that are diagonal from each other, and then you divide by the one that is paired with the unknown. Okay, one last section and then we will stop lecturing for today. We'll go through the third section. This one is proportions and problem solving. Okay, so as we're doing our proportions and problem solving, you can turn over to page 3-23 if you like. In the workbook, they initially label things. Eventually, they stop labeling things. So they do start with a little bit of labeling here. On page 3-23, it says it takes a word processor 35 minutes to spell check 10 pages. So if I'm doing this problem, I would put my minutes on the top and my pages on the bottom. So when I'm setting up my proportion, I would draw my pairs of lines. If it takes 35 minutes to spell check 10 pages, then it says find how long it would take to word process 62 pages. If I didn't have this jotted down, I could put 62 up here by accident. I want to keep my pages in the denominator, so I need to put my 62 here. So when I go to solve this, I'm going to cross multiply these two numbers and then divide by 10. So we're going to do 35 times 62 divided by 10, and that's going to give us 217. So that will be our solution, 217 minutes. Turn over to page 3-24, and we have some more of these. Let's see. In one state, 3 out of 5 college students receive financial aid. At this rate, how many of the 4,500 students at Central Community College receive financial aid? Okay, so financial aid as compared to the number of students. We're going to do a proportion, and it says 3 out of 5 students receive financial aid. So 3 get financial aid out of every 5. At this same rate, how many of the 4,500 students receive financial aid? So the 4,500 is the number of students, and then our blank is the top. So we are going to cross multiply these and divide by 5. So we have 4,500 times 3, divide by 5, that would be 2,700 students. On a scale, the scale on a map, 2 inches equals 15 miles. So we have inches as compared to miles. Draw the lines for your proportion. 2 inches is 15 miles. What is the distance between 2 points on a map that are 8 inches apart? Inches are on the top. So we're trying to calculate how many miles that would be. So we are going to multiply 8 times 15 and divide by 2. So 8 times 15, divide by 2, and we have 60. So that would be they're 60 miles apart. And actually, since 3 was so quick, we are going to go ahead and do 4 also. We will do section 4. Section 4 is congruent and similar triangles. Similar triangles have corresponding angles that are equal, and the corresponding sides are in proportion to each other. So, in other words, the corresponding sides and angles. Corresponding sides are proportionate and angles are equal. Okay, so let me give you an illustration here, and let's see what we can do with these. So if I have these two triangles, this one's labeled with a 5 and a 12. And we have a 10 in the end. So when I do this, what I would do is I would draw my two lines for my proportion. I would put the number that goes on top, I would let that be the left side of the triangle, and then my diagonal, I'm going to call that the diagonal, would be on the denominator. So for this one, my left side is 5, my diagonal is 12. When I look at this one, again, the left side is the 10, the diagonal is the unknown. So when I set up this proportion, the 2 I'm going to multiply is going to be 10 times 12 divided by 5. So 10 times 12 divided by 5. So the length, missing length is 24. Now this is one where you get a treat because I get to draw. Okay, so we have a problem that relates to some trees. A 30-foot tree cast an 18-foot shadow. Find the length of a shadow cast by a 24-foot tree. Okay, so I've got a tree, two trees. So I'm going to draw my trees. Going to give them some leaves. And then down here is the ground because it's casting a shadow. And up here is the sunshine. Okay? All right, so let's label this information. A 30-foot tree, so the height of this tree is 30 feet. It cast an 18-foot shadow. Find the length of the shadow, so that's the unknown, cast by a 24-foot tree. So when I do this, I'm going to put the height of the tree in the numerator. I'm going to put the length of the shadow in the denominator. So we have a 30-foot tree with an 18-foot shadow and a 24-foot tall tree with an unknown length of the shadow. These two we're going to multiply and divide by 30. Okay, so 18 times 24 divide by 30, and that shadow is 14.4 feet. 14.4 feet would be the length of the shadow. And we'll do one more. Okay, so for this one, we have Marcus and Steve stood side by side on a sunny day, and notice their shadows were different lengths. Okay, so I'm going to label these. We have Marcus, we have Steve, and I'm not an artist. So there's Marcus and Steve. They're each casting a shadow, which means it must be a sunny day. And here we are. We're going to set up our proportion. Okay, Marcus and Steve stood side by side. They noticed their shadows were different lengths. Marcus measured Steve's shadow. So Marcus came over here and measured Steve's shadow, determined it was 9.5 feet. So this is one you really want to draw and label so that you put things in the right place. Now Steve is going to measure Marcus's shadow here and determined it was 10.25 feet. If Steve is 6 feet tall, so let's come to Steve, he is 6 feet tall. How tall is Marcus? That's the unknown. So we are going to put the height in the numerator, and then we'll put the length of the shadow in the denominator. So Marcus is X, his shadow is 10.25. Steve is 6 with a shadow of 9.5. And at this point, we are going to cross multiply and divide by 9.5. Okay, so we have 10.25 times 6 divided by 9.5. Okay, now in my problem it says round to the nearest thousandth. So let me write down some stuff. 6.4736. 6.4736. If it says round to the nearest thousandth, round to thousandths. So tenths, hundredths, thousandths. So we would go tenths, hundredths, thousandths, 3 places. It is this 4th place that determines whether it rounds up or down. That 6 is going to make the 3 round up, and he is 6.474 feet tall.